Hey, this is Ellie from the Math Center. Today we're going to be going over related rates. So we have this problem stated here. A tank the shape of an inverted cone with base radius 3 meters and height 6 meters. The water is pumped into the tank at 7 cubic meters per minute. What is the rate at which the water level is rising when the water is 5 meters deep? So the first thing we're going to do is draw out our situation here. We're going to draw our inverted cone. And we're going to give it a radius here of 3 meters. We're going to label the height of our cone to be 6 meters. This over here is our radius. And we're going to have water inside the tank. This is being filled at a rate of 7 cubic meters per minute. So this over here, the 7 cubic meters per minute, is our change in volume over our change in time, or our dV dt. Now, we're looking for the water level, how fast the water level is rising. So the rate at which the water level is rising is denoted as dH dt. So we're trying to find dH dt. So now that we understand what the situation is and what we're trying to find, let's begin. The volume of our inverted cone is going to be 1/3 pi r squared h. We have both r and h here, which is going to be changing as it's going up, so we need to relate our r and our h. The way that we can relate this is between this height and this radius over here. So we know that r over h is always going to be equal to the ratio between 3 over 6. The ratio between our radius and our height is always going to be 3 over 6. So another way that we can write this is that r is going to be equal to h over 2. So we can rewrite our equation here, our volume equation, as v equals 1/3 pi, instead of r we put h over 2 squared, times h. And from this we get pi over 12. We have a 1/3 here. The squared turns out, so it's going to be 3 times 4, 4 from here, times h cubed. Now we're going to take the derivative of this to find dv dt. We're going to take the entire thing and take the teeth derivative of it. So we're going to find dv dt. We're using implicit differentiation, so we get 3 pi over 3 times 4 h squared times the derivative of our h, or dh dt. So these 3's cancel out. What we get from this is that our dv dt is equal to pi h squared over 4 dh dt. So we're going to move up here for our second row, and we're going to rearrange this equation. We're going to multiply both sides of this equation by 4 over pi over h squared. So we get 4 over pi h squared times dv dt is equal to dh dt. The reason we're doing this is because we want to isolate dh dt onto one side, because that is what we're looking for. Now you plug in your conditions. For example, you plug in 5 for h and 7 for your dv dt. So you have 4 over pi times 5 squared times 7 is equal to our dh dt at this moment. Or we get a final answer of 28 over 25 pi. And this is the rate at which the height is changing when the height of the water, the depth of the water, is 5 meters. I hope that this helped with related rates, and we'll see you at the Math Center.